The project identified and trialed a number of technologies for automatic passenger counting. The research was a collaboration between Swinburne's Smart Cities Research Institute, Transport for New South Wales and Sydney Trains, and the iMOVE Cooperative Research Centre.
The objective from Sydney Trains was counting the number of passengers on the replacement bus, such that they can forecast how many buses they would need in order to provide service.
Looking at how we could automate the process of counting passengers on these buses. And because we're talking about real-world buses, we have to think about the real-world conditions in which that has to work. We came up with 4 different options to provide, and then we came together to find a way to develop those technologies and compare them. For the vision-based solution, we had cameras mounted above the doorways, but we're also looking at other vantage points, including just a bit back from the door, so that we could track passengers a little bit more easily as they entered or exited the buses. What we were looking at here was using state-of-the-art deep neural networks as the key to our solution, using them to detect people reliably, particularly under the real-world conditions that we were dealing with a bus with lots of variable lighting conditions, vibration, lots of issues that come up, which in general for computer vision are big challenges. So we were looking at how well these techniques would work in this particular context, and then seeing how we could improve on those.
We've been working with pressure sensors for a very long time, and we had a couple of solutions at hand which had to be trialed beforehand in our laboratory, and then we had to produce the actual prototype. We had 24 sensors on the sensor mat, which then were able to tell us in the direction in which people are going.
Mobile sensing works really well for people counting, but you have to make sure that the environment is right for it. The special challenge with us was that we were trying this in a moving environment. We need to put our sensors all over the bus to have some way of locating the person's phone. And then, judging by how many of our sensors can sense a certain probe request, we can say it's likely to be on the bus or it's unlikely to be on the bus. If you shield it appropriately, it'll work much better.
This sensor is particularly good in crowded environments because by measuring the distance you can separate different people. With a camera, if people wearing the same colors, it's very difficult to separate. It guarantees privacy also, because you can tell whom the sensor is actually watching.
The project demonstrated how we can converge meaningful technology with infrastructure and existing assets to provide a better user experience. Understanding how many people are using these replacement services can provide insights, especially in how the organization can reduce costs while at the same time maintaining high customer satisfaction.
From doing the field trials, we were able to learn a lot more about what we need to be handling for a real-world deployed system, which is what we're looking at now, is how we can further improve these techniques.
We were delighted to work with partners who share the same vision about future cities and about the role of digital innovations in creating a sustainable world.